All right, so we are going to be looking at integrals involving powers of secant and tangent in this video. These are your guidelines. If you are using our textbook, it is page 539. You're going to want to refer to these guidelines when you're going through these problems, doing your homework. So if the power of the secant is even and positive, save a secant squared factor and convert the remaining factors to tangents and then expand and integrate. So we're going to just keep this in mind when we're going through the problem. So if the secant is even, we're going to come back to this and look at what we want to do. If the power of the tangent is odd and positive, if the power of the tangent is odd and positive, save a secant tangent factor, because secant tangent has an antiderivative that we can find, it's just secant. So that's the whole purpose of doing that. Saving those pieces. And then if there are no secant factors and the power of the tangent is even and positive, convert a tangent squared factor to a secant squared factor, expand and repeat as necessary. And then we have number 4, if the integral is of the form secant of m to the x, where m is odd and positive, use integration by parts as illustrated in example 5 from section 8.2. Integration by parts. And number 5, if none of the first 4 guidelines applies, try converting to sines and cosines. All right, so let's look at an example. In our, so this is my 4th example from this lesson. So if you look at this, we have a tangent that is odd, we have a secant that's a fraction. So we have when we have tangent is odd, we are odd and positive, save a secant tangent factor and convert the remaining factors to secant, expand and integrate. That's where we're at. All right, so I'm going to rewrite this as secant of x to the negative 1/2 power. So I'm going to bring that secant up, and then I'm going to, then I have tangent cubed x dx. All right, that's just bringing up and turning the exponent into a negative. All right, next step, I'm going to convert to secant x tangent x. I have, so if I want to get a secant tangent, what I'm going to do here is I'm going to take my secant of x and I'm going to take this to the negative 3/2 power, multiply that by a secant of x. If you think about this, if you add your exponents together, because this is to the first, you add those exponents together, you would get the same thing as secant to the negative 1/2. So that's equivalent to secant to the negative 1/2 power. So that's a trick that you can use. And then we have tangent cubed, so I can split that into tangent squared x times another tangent. And that way I'm going to get my secant tangent x that I want. And I'm going to take this tangent squared x, I'm going to use a Pythagorean identity. Tangent squared x plus 1 is equal to secant squared x. So that means tangent squared x is equal to secant squared x minus 1. So I'm going to substitute that in place of this tangent squared. So equals secant to the negative 3/2 x, and I'm going to move this secant next to this tangent over here. I'm subbing in secant squared x minus 1 for tangent squared x, and then I have secant x tangent x dx. That's a 3/2. All right, and now if I distribute the secant to the negative 3/2 through here, I'm going to get, add your exponents, negative 3/2 plus 2. Add negative 3/2 to 2, we'd have 4. This would become multiplied by 2 on the top and bottom, and you'd end up with 1/2. So the negative 3 plus 4 would be 1/2. So this times this is secant to the 1/2 power x minus secant to the negative 3/2 x, multiplying that by a -1. And I've got that times secant of x, tangent of x, dx. All right, now we're going to use some u substitution and see if you guys can do it on your own. Pause the video, try to finish this problem off. I'm going to continue here. So if I use u substitution and let u equal the secant of x, then du is secant x tangent x, which is the whole reason I wanted to get this piece here, because now it's equal to my du. And using u substitution, I can take, this is u to the 1/2 minus u to the negative 3/2, and this entire piece over here is du. So now integrate using the power rule. So I have u to the, add 1 to the exponent, that becomes 3/2, and I have to multiply by 2/3 out front, minus u to the negative 1/2, multiply by a -2 out front, so that becomes +2. And then plus c. And now I'm going to throw back the u into this, so I have 2/3 secant to the 3/2 x plus 2 secant to the negative 1/2 x plus c.